Welcome to This Explainer. Today, we're looking at what might literally be the most fascinating dynamic of our entire generation: the biological brain versus the artificial neural network. We're diving straight into the data to see how our own human cognition actually measures up against modern machine learning, and more importantly, where this rapidly evolving partnership is heading. Okay, let's dive into this. It's the question dominating headlines, right? You hear it at dinner table conversations, in the news. Are these highly advanced models fundamentally replacing human thought? Or are they really just catching up to a tiny fraction of what our minds do naturally, effortlessly, every single day? Well, let's look closely at the architecture of both types of intelligence to find out. So here is our roadmap for the breakdown. First, brain versus the machine. Second, inside neural networks. Third, the intelligence showdown. Fourth, flaws in the machine. And finally, we'll wrap up with the hybrid future. Section 1. Brain versus the machine, biological inspiration. So what exactly is an artificial neural network, or ANN? At its core, it's a computational model that is directly inspired by your own brain. Back in the 1940s, researchers like Warren McCulloch and Walter Pitts started developing these mathematical models of artificial neurons just to represent basic logical functions. And the ultimate goal? To replicate the intricate, beautifully interconnected wiring of biological neurons. Information passes through these artificial nodes via connections, much like signals travel through the axons and synapses right now inside our heads. But here's the catch. While they share that biological inspiration, how they actually function differs wildly. Biological neurons absolutely thrive on lived experience. I mean, human learning is incredibly context-rich and super adaptable. We're capable of what researchers call one-shot learning. That means you and I can form a really complex abstraction from just a single, isolated example. Artificial nodes, on the other hand, they are entirely data-driven and strictly algorithm-based. They're highly specialized, sure, but they frequently demand thousands, if not millions of data points just to recognize the simplest pattern. Moving on to Section 2. Inside neural networks, how the machine learns. Okay, so learning in a neural network basically happens in a three-step dance across distinct layers. First up, the input layer receives the raw external data. Simple enough. Second, that signal moves through one or more hidden layers. Now, inside these hidden layers, the connections have specific weights and biases. Think of them like little volume dials that either amplify or dampen the signal. Finally, it reaches the output layer. Now, if the network makes a mistake, which it will, a loss function evaluates that error. Then, using a really neat mathematical process called backpropagation, the network works backward, adjusting all those little dials, those weights, to minimize the error for the next time. It's mathematically complex for sure, but conceptually, it's actually very similar to a human just learning from a mistake. Within that architecture, the machine can be trained using three main paradigms. First, you've got supervised learning. This relies on feeding the machine explicitly labeled data, like literally showing it a million photos explicitly labeled cat. Then there's unsupervised learning, which hands the machine raw, totally unlabeled data and just asks it to find hidden patterns on its own. And finally, reinforcement learning. This is actually a lot like training a pet, except instead of giving it a physical treat, you're maximizing a mathematical reward. But remember, and this is absolutely crucial, all of these methods require massive, massive amounts of data compared to everyday human cognition. Section 3. The intelligence showdown, a comparative breakdown. Now, what's really interesting about this comparison is seeing exactly where each side shines. When we look at pure processing, the sheer scale of the machine's advantage is, frankly, staggering. Once it's trained, an AI system has insanely high speed and massive scalability. It operates 24/7, no sleep, no coffee breaks, no burnout. It is custom-built for high-throughput tasks, things like global fraud detection or processing millions of instances in mere seconds. Us humans, on the biological side, operate at a much more moderate speed. We're heavily limited by our cognitive load, our attention spans, and just basic physical fatigue. So, in a pure numbers game, no question, the machine wins. Yes, but let's flip the script for a second, because this is where human intelligence truly, undeniably dominates. We possess original creativity. It's driven by real intent and rich lived experience. We have genuine emotion and real moral accountability. AI, on the flip side, relies entirely on pattern-based outputs. Sure, generative models can pump out poetry or paint incredible pictures, but let's be real, they are just recombining learned statistical motifs. There's no intent behind it. AI can simulate empathy through a slick chatbot, absolutely, but it doesn't actually feel anything, and it inherently lacks any true grounded moral reasoning. Section 4. Flaws in the machine, the Achilles heel of AI. Because despite all that blazing speed, the vulnerabilities here are significant. First up is dataset bias. Neural networks only learn from the data we feed them. So if our historical data contains societal inequalities, the AI is just going to learn and blindly perpetuate them. There's actually a famous real-world example where a major tech company had to completely scrap an AI recruiting tool. Why? Because it had learned to heavily favor male candidates over female candidates, entirely based on skewed past hiring data. Then we have concept drift. This is where a model just flat out fails because the real world changes and suddenly its old training data no longer applies. And finally, fragility. Minor, almost invisible little tweaks, what we call adversarial perturbations, can cause an AI to completely misclassify an object. We're talking about visual tricks that a human toddler would never, ever be fooled by. And this brings us to a major criticism, perfectly summarized by technology writer Roger Bridgman. He noted that the numbers capturing a neural network's behavior can often be an opaque, unreadable table, valueless as a scientific resource. This completely hits the nail on the head regarding the black box nature of deep learning. A model might spit out the perfectly correct answer, but its internal hidden layers are so vastly, unfathomably complex that we humans often cannot even interpret how the machine actually arrived at its conclusion. Which leads us to Section 5, the hybrid future, us with them. So, the crucial point is, where do we go from here? What does this collaboration actually look like out in the real world? Let's take healthcare. AI takes on the heavy lifting, processing millions of pixels for hyper-fast pattern recognition in radiology imaging. The human role, clinical judgment, nuanced ethical decision-making, and looking a patient in the eye to deliver empathetic care. Or look at education. The machine handles the grunt work of tailored learning pathways and automated grading, which frees up the human teacher to do what they do best, provide genuine emotional support, mentorship, and real guidance. And we see the exact same dynamic applying across other industries too. In the creative arts, AI acts as a seriously powerful tool for rapid prototyping and spinning up generative drafts. But humans, we drive the original concept, the careful curation, and we provide the actual soul of the story. In customer service, AI steps in as the first line of defense, effortlessly handling basic, routine inquiries 24/7. But the moment a situation becomes complex, nuanced, or highly sensitive, it gets handed right over to human judgment. The machine brings the raw efficiency, we bring the humanity. To actually achieve this balanced future, the research outlines 3 key recommendations we need to act on. First, we desperately need strong policy and governance to ensure these systems stay fair, transparent, and unbiased. Second, we've got to focus heavily on workforce reskilling. As those routine tasks inevitably get automated, our education systems must pivot toward lifelong learning, critical thinking, and complex social skills. And finally, we most intentionally design human-in-the-loop systems. This just means ensuring that for any high-stakes decision, a human is firmly empowered and properly informed to make the final call. So we've covered a lot of ground. We've seen how the biological brain originally inspired the artificial note. We've seen how their unique strengths and weaknesses actually offset one another perfectly. And hopefully, we've seen how the future isn't about human replacement. It's about powerful synergy. As the lines between human intuition and machine efficiency keep blurring, the ultimate question is no longer whether AI is going to change our world. It already is. The real question is, how will you adapt your own uniquely human skills to collaborate with the machine? Keep learning, stay curious, and we'll see you in the next explainer.